Let's welcome to the class Design and Analysis of Algorithm, Unit 1 syllabus. This is our syllabus to cover about, I'm going to cover the fundamentals, design paradigms, asymptotic notations, regressions, rotations. In the class 1, we are going to cover only the introductions of algorithms. Basically, the algorithm word is derived by the mathematician scientist Abu Ja'far Muhammad ibn I Musa al-Khwarizmi, and this is algorithm is there. He is saying that it is maybe a set of instruction. The instruction sequence should be a clear and finite. Each instruction should be clear and there is no confused statements, and it should be in a correct one for the problem. And every instructions have to validate by giving input. So the set of instruction is processing, and finally it may produce the output. The value is nothing but p, means after that it should be terminated. So let's say algorithm is a sequence of instructions or step-by-step procedure to solve different kinds of problems. So here I took example for prepare the cake. So this is ingredients is called as inputs. Example: egg, flour, cocoa powder and blender. These are the important things for prepare the cake. So we can say as a inputs. And prepare, how to prepare, that is a procedures. Follow the instruction to be prepare. For example, first of all we'll take the egg and we'll mix with that flour powder and we'll add all ingredients, cheese, everything, and we will prepare in the shape and keep it in the oven. Like this, the process is a procedure. Then finally we got the cake and we will add some decorations, we'll add some more cocoa, everything. No, so finally we'll get the output, that is called as a result. So likewise, in the technically we will see the algorithms, the fundamentals covered. First of all, we'll see the definitions. We know that is a set of rules to be achieved the desired output, especially by the computer takes an algorithm as an input, and we will write the coding based on that algorithm. And I will for write the coding, I choose the programming language such as C, C++, Python. So which one is more suitable and comfortable to my user and getting clear output, I can choose that coding based on our problems. Finally, I will get the output. So the computational procedure may take some value or set of values as an input and may produce at least one result or maybe a set of result. So this is all algorithms should satisfy the following criteria. First one is the input. So this is the characteristics. Input in maybe a zero value or a single input value I can give. And output, algorithm must produce at least one output. Then finiteness, algorithm should be terminate in a good end. It should be terminate with finite number of steps. And definiteness is nothing but each steps of algorithm should be correct, should be defined clearly. Effectiveness, algorithm operations should be performed well, it should give an exact results. Let's discuss about the types of algorithm. Based on the user requirements, the problem has been designed. So the problem designed is depends on the categories of algorithm. So my problem is a mathematical problem, and even it is like a Fibonacci series or factorial, means I can choose recursive algorithms. Recursive function is for nothing but the function calling by itself, it will track. Or I'm using the backtracking algorithm for finding the shortest path, and which one is the best path, means I can use the backtracking algorithms. Example, our real-time example in the Google map, we are finding the smallest path, using the Olo app or Uber Auto, they are utilizing the shortest path and best path, so that one. And like this, we have different kinds of algorithm, that is called dynamic programming greedy algorithms, branch and bound, brute force algorithm, randomized algorithm. These are the topics we'll discuss in a upcoming units. And understanding of algorithm. Algorithms should be an unambiguous instruction for solving the problem. We know that, see the diagram, once the input has to be given to the computer has consists of an algorithm. This is giving the solutions to the problem. So it may get one legitimate input and it will process and it will produce the output. Algorithm analysis design. So this is the fundamental strategies for solving a problem. These are the procedure steps. First one is understand the problem clearly. That is what for which problem you have taken and what algorithm you are going to be right. You should have a clear idea and you should have what type of input you gave, what will be the output, everything. You have a certain list of questions, you have to know answer for those questions. Okay, what to do, how to do, and what the output will achieve, the goal of the problem, everything should be defined clearly. And next one is to decide on whether my problem can be a solvable, that is exactly give the result, or it may give approximate result. That one should be defined clearly. Exactly problem solving nothing but it may give the definite output, exact output. For example, 5 factorial, what will give the round value 120. Okay, that is called exact problem solving type. Approximate solving type na, the problem may be, for example, human populations count. In India, in our country, if you want to calculate the human population, means we can't predicate the exact count at a time, because per minute, per second, in the fraction of seconds, few persons may born and some of you may fall in death, isn't it? So we cannot exactly predicate that count. So that is type of problems is called approximate solving type. And we choose the data structures. What type of designing structures you are going to use in your problem. Example, we have an arrays structure, linked list, like that. So we have to choose the designing procedures, and we have to use the algorithm designing techniques. The designing techniques we have, and a different designing techniques we have. Example, we have a we have a flowchart method and the pseudocode or natural language. Flowchart method is nothing but it is in a pictorial representations of problems. We can use the symbols, for example, start symbol, end symbol, and we have a rectangle for defining your processing statements, and reading and input statements are defined with parallelogram symbols. Like this we can represent through the symbol. And pseudocode is nothing but it is like a start, end, end, and if you want to declare the header files, means int space variable name. So like this format it has contains. So natural language is nothing but it is like a just English statements. And proving the correctness. The correctness of programs can be proved by giving a proper input. It may produce the correct result, means it is a correct algorithm. Suppose it may not produce the perfect output, means there is a mistake. So we have to recorrect the coding statement, that is algorithms, and we have to check it. Okay, once your algorithm instructions has been defined, then we check the efficiency of the algorithm. How to check the efficiency? That is the performance has been validated by the time and space computations. That is how much time it takes run the code and how much space is occupied for algorithms in lines and executions. Then coding. Once you have defined all, you must choose the good program code, maybe a C code or C++, like that program code as we choose. Then fundamental analysis of algorithms efficiency. Algorithms analysis framework, there are two kinds of efficiencies there. One is the time efficiency, another one is the space efficiency. Time efficiency is defined how fast algorithms is work. Okay, how my algorithms work quickly, how it may gives output. And a space, how it deals with space, how much space it occupied for algorithms. Okay, how much space it requires for executions, that and all we discuss. And analysis of iterative algorithms. In this analysis of iterative algorithm, we concentrate in the two things. One is the measuring input size and measuring running time. So measuring input size, the it is depends on size of the input. If suppose if my programs is n number of for sorting means I can, yeah, if I'm giving n value is 5 means it will quickly complete the task. Suppose if my n input value is 1000 means it may takes 1000 inputs for processing and for sorting, right? So the input size is depends on the type of values. The sorting numbers now it is an integer type, so it will, we can use some array of structure to collect the values, and we can count, we can complete that. So each number may be represents in the number of bits, we can represent in a bit terms. So like we can use the graph matrix like that. Example, if I here I mentioned that n by n matrix. So the here computing the product of two n by n matrix la, there are two natural measure of size for this problem. Two natural numbers has to be, that is two natural measures has to be defined. And matrix order, suppose my n order is 2, not 2 cross 2 matrix, and my order is 3 now, 3 cross 3 matrix. So based on that, structures will be differ and the input sizes will be differ, and the total number of n elements in the matrix to be being multiplied. That is the things to be defined. And measuring running time, the running time of algorithm are defined in the various term. First one is the step count. This is the yearly generation time. The measure, this is the measuring unit of the algorithm's efficiency. In real time we are using no for rice, for measuring the rice means we are saying as a 1 kg of 1 kg or 2 kilograms of rice, rice packet or 25 kg rice packet, like that. Here we are measuring the unit time is step count, that is number of lines in the algorithm. This is proposed by scientist Ullman. Basically, it is based on the RAM model. The set of instruction is